Okay, good afternoon, everybody. My name's Andy Stevenson. I'm the chair of the Teesside Committee of the Institution of Mechanical Engineers, based in North East England, and I'm pleased to welcome you to what is now our 6th Tech Talk event. So we have two chartered engineers speaking with us today, both from Hitachi Rail. They are Katerina Dellianni and Thomas Colantuono. Both design engineers who are going to talk about their work at Hitachi. So as a reminder, over the last few months, we've had a wide range of talks on things as diverse as subsea cables, canal barges, flattener rotors, offshore wind farms, and the Teesside Net Zero project. Recordings of all of these can be viewed on the IMechE's YouTube channel. So I would encourage you to go and have a look if you didn't manage to get along to some of those events. Our next event towards the end of July is going to be on pipeline failure and inspection with speakers from Rosen and Durham University. So please look out for details on that on the IMechE Near You website. And as a reminder, we're always keen on any other volunteers getting involved. So if you have an idea for a short technical talk at a future event on any mechanical engineering based topic, please get in touch with me via the email address shown on the screen or through the IMechE's Near You website. Okay, so thanks very much for joining us today. I'll now hand over to Thomas, who's going to get the first talk underway. Over to you, Thomas.
Good afternoon, everyone. It's Thomas Colantuono speaking. I am a design engineer working in the UK design engineering department at Hitachi Rail Limited. And today I'm going to present essentially this presentation that is titled Piping System Design, Acting Locally, Thinking and Working Globally. Essentially this presentation, after a brief introduction of my previous background, will go through like some examples to show the role of the design piping system engineer in at the Hitachi Rail, and also it will show all the team effort to make possible the building of great trains that we are delivering across the UK. And the piping system design will be just an example because it's what is my day-to-day activity to show also what is like a general workflow at Hitachi and what are also the opportunities and challenges. So the contents will be a brief introduction of myself, the role of the design engineer, a common effort, the teamwork, challenge and opportunities, and then there will be a session for you for some questions and answers. We hope that we can reply as much as possible. So regarding myself, apart from the fact that, just going back. As I told you, I'm Thomas Colantuono. I have been nominated a chartered engineer on the 20th of January of this year, and my previous academic background is formed by a bachelor degree in civil transportation engineering and a master engineering degree in mechanical engineering. Previous working experience includes the role of the research assistant at the University of Huddersfield at the Institute of Railway Research, and I'm currently working as a design engineer at Hitachi Rail Limited in the Northeast, so in the factory of Newton Aycliffe, in the manufacturing facility of Newton Aycliffe, which is located in Durham County. The role of the design engineer, we are going straight into essentially the piping area. So this slide that I am projecting is showing essentially a piece of the underframe of the train. So if you look here from this point to this point, from the suspension on the left-hand side to the other air suspension module on the right hand side, essentially we have an underframe car body which is a length of around 12 meters, and in this, what I would like to highlight with this slide is that, as you can see, this one is just an underframe under development, yeah. And essentially, I can recognize like a lot of components. So we have a battery box, we have a dead mass, we have also an a wire duct for a low voltage. We have the traction converter on the right-hand side, and before there is the brake module. And here, if you can see, there are some pipes that are going through. The design of the pipe itself is really simple and pretty straight. Today, there are some software that allows to make a pipe easily, routing the pipe easily, define the wall thickness. What is really complex is the environment, because I have to interface with a lot of components, and also there are like minimum distances between surrounding components, and the environment is quite complex. And the other big challenge is that pipes on the train are everywhere. We have pipe for different applications. So today I'm going through some example regarding pneumatic pipes. But essentially, we have drainage pipe, we have pipe for HVAC system, we have pipe for that works as a carrier for wire or for board and cable. The example that is in this slide is an example regarding an individual pipe. I want just to inform you regarding which are the main specifications and informations that I require to make a pipe, and also to provide to a potential supplier to manufacture the pipe, or you can bend the pipe in-house if you have the facility. So essentially, as you can see here, what is important to me to know is the application of the pipe. So if it's pneumatic, draining pipe, or carrier. And this information generally comes from the schematics. So the schematics are provided by a system integration engineer, and generally I have to have a good understanding of the schematics because the schematics gives you a lot of information. For instance, with reference to this pipe that is on the right-hand side, I summarized some interesting spec and values in these tables. So essential, this pipe on the right-hand side is a pipe for a main reservoir. It's a main reservoir pipe, and I have the material, which is copper. I have the total length of the straight pipe before manipulating the tube and before bending it, the outside diameter and the thickness. The information, especially on the functionality of the pipe, the outside diameter and the wall thickness, are generally present on the schematics. Plus, the schematics gives you an indications from the points that the pipes or the system of pipes or multiple pipes have to connect. For instance, we are going from the brake cylinder, in the bogie area until the brake module, and I have to essentially draw and design the pipes that allow this connection. And an important information regarding the individual pipes in order to allow to a manufacturer to manufacture this component is essentially, apart from the material, the outside diameter and the thickness, the pre-cut length, which is essentially this one, is this 5.7 meter. And because, of course, the raw material is given to the supplier in batches of 6 meters, and you have to pre-cut the pipe and putting in the bending machine. And what is really important is this table with all the X, Y, Z and bending informations. This one can be provided as a step file from the 3D model, or can be also provided as a summary report that you can download. And I always attach, when I make a new pipe, I always attach this information to the final drawing that will be given to a supplier or to a final user. The other things that I want to mention with this slide is that we can make individual pipes and fit the pipes in the underframe of the train, for instance, or we can make a more complex drawing to ask to the supplier or to make an on-the-bench work regarding pipe modules. So essentially, we are moving from a single pipes to a pipe module. A pipe module incorporates, embeds like brackets, clamps, fittings, and valves when required. And essentially, why we decide to go for this direction, because we can, let's say, tell to a supplier to do this activity on the bench, and then we receive some pipe already, some sub-assemblies that are ready to be fitted in the underframe. There is a small picture here where essentially is shown some wiring and piping work, and there are some modules that essentially represent the skeleton of the piping system that are fitted straight away. And this one, it would be quite advantageous, mainly for the design for manufacturing concept, because we'll reduce the installations time. This is essentially my day-to-day activity as a piping resident engineer. I want to show what is the full workflow that brings to a successful design of pipes. So essentially, the first boxes in red on the left-hand side, the piping system engineering spec and piping design, is all the engineering side. Let's say it's our area. However, after that I receive the spec and we make the design, then there will be all the manufacturing and procurement activities to create the manufacturing bill of material and the purchase list. The supplier designations, that is done via a localization process. Then we going through, there is all the material flow, so all the supply chain, and then the train building, so the production. Then, of course, there will be the full train testing activity, because all the pneumatic system, for instance, is tested, the full train commissioning with the free fault running, and the train also will be then into passenger service. So I bespoke this example for the piping system, but this is essentially all the departments and all the engagement that is required to make the train into passenger service like possible, for the successful outcome. So essentially, this is why I want to highlight the fact that the collaborations with the other design engineers to check the interfacing point, collaborations with system integration engineer, with suppliers, with customer needs, and also with the focus on passenger service and to deliver the benefit is really, really important to make everything possible. The other things that I would like to highlight, like regarding testing activity, I'm not a test engineer, but all these pneumatics, for instance, the pneumatic system that is probably the most important applications that I'm dealing with, is essentially always tested full train. Our pneumatic system, of course, we are in train, so we are talking about of operating pressure up to 10 bar. So compare, I don't know if among the audience there will be people from other industries, for instance, oil and gas. So the pressures that we are dealing with are really low pressure compared to other applications. And all this teamwork essentially that is applied in various branches and in various areas of the train allowed us to deliver successfully across the UK, like different fleets. Just to explain a bit regarding Hitachi World, so generally we delivered in train working in platform. So the 80-100 platform, which is not on this slide, is a metro system, and we are actually building for Italy a metro system. Then the 80-100 platform is regarding commuter trains, and we delivered the Abellio ScotRail that is running between Glasgow and Edinburgh. The APT 300 platform is all the intercity trains. We have a lot of examples. For instance, this one that is in the picture set on top is the Azuma train that is running between London and Edinburgh on the East Coast Main Line. And plus, of course, there is the 8400 platform that will be the high-speed trains. So in this case, would be HS2. We recently submitted we have recently submitted the bidding, and we will see the outcome. But essentially, we work on platform, and all this platform will be developed further every time. So it might be that there are a new baseline of platform where we change more a lot of structural parts of the trains, or between one train and another, we can change a lot of interior components based also on customer requests. So we are constantly focused to evolve and develop our product based on customer needs, technical specifications, passenger also needs. And just to summarize some challenges and opportunity that derives from my day-to-day activity as a pipe resident engineer. Now, one of the aspects is the piping system. As I told you, is a simple design if we look at the individual pipes, because it probably takes less than 10-15 minutes to design one pipe with the tooling and software that we have today. However, the real complexity is that the understanding of the spec and the points that you have to connect, and also all the interfacing parts, and if you have enough clearance with the surrounding components. We try to use in the Newton Aycliffe, the manufacturing facility in which I work, a design for manufacturing approach, which I think it's quite unique. I would like to speak with the other design engineers, because many people think that design activity just terminates, or probably this is just their job, just doing design and 3D. In reality, we are involved in a lot of cross-functional meetings, and there is a lot of collaboration. And in this case, the design for manufacturing is an important aspect, because we are always designing, focusing on the how to reduce the installations time, how to reduce how to simplify the installations. The pipework production schedule is something that I'm not directly involved, but to me, this one is always a challenging topic, because the pipes can change at until the very last minute. However, they are the first parts to be installed on the train, and the 75-80% of the pipework is installed in the first 4 production days. So if there is any delay in the design, this one will affect the procurement activities, the provision of the parts, and will affect also the production. So this one is something that I always really pay attention. Also because in our industry, in the railway industry, we just build bespoke product. It's not a large amount of component like could be the automotive, but it's just a bespoke product, and the change can happen anytime. Another aspect that I would like to raise is the digitization process. So what happened is that in the recent time, in our company went live a software that allows a product like life cycle management of all the technical information, and this system essentially is connected to the 3D software, and allows you to create essentially the bill of material of the train, the bill of material of the area. And it's quite good because drawing can be released, can be sketched, can be reviewed, approved from anywhere in the world. So, for instance, there are a lot of projects in which we collaborate with our partners that are in Japan or in Italy, and you can have a drawing that has been submitted in the UK and approved in Italy, and the other way around. And my reflection in these days was that this system came at the right moment due to the pandemic and the COVID-19, because essentially we can carry on with all our activities, all our design activities, without affecting too much our efficiency, because a lot of people are now working from home. The only support that we cannot offer at the moment is like a full-time production support, as also we were doing before. The other challenge and opportunity at the same time is always the stakeholder management. So customer, suppliers, internal stakeholders. It's a challenge because of sometimes of the requests, but there are also many opportunities because it's always an enrichment, to have this kind of feedback, conversation, technical exchange, and that's everything on my side. So if there are any questions, I would be more than welcome to reply. I hope that thank you for your attentions, and I hope that you don't get bored.
Hi, Thomas. Can I ask you a question while we wait for some other questions to come in?
Yes.
So in terms of the pipe that you showed us, could you give us a bit of an idea how long that takes to develop from a concept through to the final manufacturing drawings?
Yes. Now for the pipe module itself, the one that I displayed with the brackets and fitting, only the individual modules, the development in total could be less than 1 week for the design and also for managing also the informations of the bill of material. Plus, of course, then there will be a procurement time for selecting the supplier. But let us say, assuming that we already selected the supplier, and the supplier has got all the components for making a module, I would say 1 day for making one pipe modules, and probably maximum 1 week of design for one pipe module. What is really challenging is when you have to create from scratch an entire underframe, let's say, because in that case, it might take even longer, So generally, when you work on platform, you have some content of your pipework that let's say is a kind of you can reuse because we have library also of pipes. It's changed when you have to design from scratch because it's not only the pipe itself. You have to take into account all the interfaces. But one pipe module, I would say 1 week maximum of design with all the management also of the technical information, bill of material, the approval process, because there will be different steps and it doesn't rely only on you.
Okay, thanks. Well, we've got a few questions coming in from other people listening in. Can you just tell us a little bit about how the pipework vibration is considered within its design?
All these aspects generally are managed, so are not managed directly by myself. So it's always I know what is the background, let's say, on vibrations in terms that generally I always have a liaison with the system integration engineer, that works in collaboration with also the provider of the braking system, essentially. And I know that there are testing on these. when, of course, we are delivering a new platform, there are always proto train, in which, of course, there will be vibration testing, and there will be also some dynamic testing of the system. Well, the dynamic testing of the train as a full, but yes, it's not directly me. In fact, when I have the other specifications, the other specifications are already from all the other engineers. The other aspect is that if you take, for instance, one car, is that all the pipework system is probably around in one car for at least the pneumatic, the ones in the underframe is around 300 kilograms. So there are more also like there are components that are even heavier, yeah. So my pipes are distributed and are quite light compared to other components. So this one will also affect the vibration distribution. Also, what normally is done during the testing activity, as far as I know. So when they are testing the train, so what is really important, they are putting the maximum pressure of 10 bar inside the system. Yeah, probably this one might reply to the queries, and they check every type of, well, if there is any leakage between the fitting or the valves and the system itself. But in terms of the vibration that are transmitted, I think that there are also other heavier components that will take probably a bit more. And in any case, the majority of the vibration would be on the holding point of the pipework, so on the bracketry itself. I don't do any direct study on vibrations anyway.
Okay, thanks for that, Thomas. We've got another question asking, how do you adapt the design when the customer's got specific requirements? For example, temperature-related design requirements?
Temperature-related design requirements. So
if the customer has a specific requirement, is that addressed at the start of your design process in your design specification?
Well, generally, yeah. I've never found any type of these specifications, even if when I worked on previous project in the technical specifications, I've never found this type of specifications. It might be that if we are considering, let's say, it's not the pneumatic system, but if we are considering like thinking to the generator unit, so on diesel train, it might be that there are temperature specifications. It's not an area that I'm dealing with because that one is it's considered a subsystem. So I have another design engineer, and I know that on system, of course, there will be temperature requirements on the pipe itself. I've never received for these applications. Again, we are up to them bar any type of temperature spec.
Okay, thanks. So one final question, Thomas. You talked a little bit about using the software.
Yep.
Somebody's asking what kind of maybe policies or procedures are used to double check the software in terms of the section sizes and the design, and are hand calculations still used?
Actually, I don't use. I use Creo as a software, and if you make the individual pipes, there is no need of any hand calculation. So essentially, what I have to do generally, I use the piping routing, which is in the assembly environment. So, and essentially, you have your connection point in the assembly environment, and you have just to route the pipe. So you can place, let's say, I always place. Well, this one it's not a secret, but I always recommend to place like a 3D relative reference system, a 3D relative system at the beginning of the pipe. because then you can just extrude your pipe after defining, of course, the thickness and the size. And then, because you have placed this system, then you can ask to the software to make a report based on that reference system, and essentially will give you all the local informations. So if you want to make from scratch the pipe, this is probably the best approach. Another approach that I'm trying to study, but the thing is that at the moment the company, I don't know if we'll invest the money on these directions, because it will imply modifications on the Creo opening file. So is essentially that you can work. There are some Excel spreadsheets that are linked to the opening files of Creo, where you can actually create library of components in a better way, and also probably having already the XYZ dimensions, because if you do one by one, it could be a bit time consuming. But honestly, if you design the pipe starting from a reference point, then you can ask all the informations based on that reference point. And this one is what I will put on the drawing. So this means that there will be a reference system every time that I create a new single pipe. Because this one, when I have, after that I do the full assembly, essentially I can retrieve information of every single pipe. So,
okay.
And I don't know if I answered the query.
So if it's okay, we'll pass on to Katrina, if that's all right, Katrina.
Yeah, that's fine. Thank you very much, Thomas.
And again, if anyone's got any questions, they can send them through while Katrina's giving her presentation. So I'll pass across to you now, Katrina.
Yeah, that's great. Thank you very much, Andy. Thank you for your introduction at the beginning as well. So I'm Katerina Dellianni. I'm a chartered engineer for the Institute of Mechanical Engineering, and I've been a full-time design engineer for Hitachi Rail based at the manufacturing site in Newton Aycliffe since May 2016. Today I'm going to give you a short overview of the mechanical design for trains and talk more in detail about the development of saloon interiors design and train system integration. I'll start with a short introduction about the content of this presentation. I'll talk about the global team we've got of engineering and explain some examples of mechanical design for trains. I will also make a note of the development for the design in the saloon interiors and give you a few examples of the train system integration that's happening currently in our ongoing projects. So the aim of this presentation is describing in a nutshell the life cycle of train vehicle design and manufacturing for Hitachi Rail. I'll present an overview of the various design engineering teams across the globe who work towards the same train design delivery, and show you how essential it is to have a combination of great design engineering expertise, practical experience, and obviously the input of new technology in our work. I'll show you a breakdown of a train so you can understand better the various locations on a train vehicle which are prone to design changes and customization. The mechanical integration of train systems in the saloon interiors are mainly coming from our passengers' requirements, and this is what leads our design, our day-to-day work. Obviously, testing and compliance control, especially for the saloon interiors area where passengers are more located, is essential and helps us to freeze our design and proceed with the manufacturing. Historically, the car body cells were welded and painted in our manufacturing facility in Kasado, which is located in the Yamaguchi Prefecture in Japan, and also in Pistoia in Italy. Nowadays, we've got a new establishment ready in Newton Aycliffe, where we'll start taking up the welding and painting work. The design engineering work, though, has been established in the UK since the opening of our manufacturing facility at Newton Aycliffe in 2015. Currently, the design work takes place in all design Hitachi Rail sites, including Newton Aycliffe site in Pistoia and in Kasado. On this slide, you can see on the left-hand side a picture of a train interior at the state of delivery at our manufacturing site in Newton Aycliffe. So train vehicles arrive at Newton Aycliffe as bare car body cells, welded and painted at the exterior. On the right-hand side, you can see the team members have entered the saloon, the interior of the car body, and have started the assembly process. On the right-hand side, you can see a picture of the front end of the vehicle where the cab is located. So you can see that the team members have started with the rigging work. Piping and wiring are first procedures in our assembly facility that take place at the very beginning of the manufacturing process. On this slide, you can see a side view of a leading vehicle taken from our IP fleet. So this is our Intercity Express program train. As it's a leading car, you can see on the left-hand side is the cab area where the driver sits. You can see at the exterior we've got the bogies, we've got obviously the doors where passengers can enter the train service. There's a separate door for the driver at the cab area. Looking at the top of the side view, you can see there is a node for the cab HVAC system, and towards the back end of this section view you can see the location of the pantograph, which is located in both leading cars of the train unit. Across the side you can see obviously the windows. Some of them are highlighted as dummy windows, because, as you may see on a later slide, these are taken by the catering area, which is located in this specific leading car. The rest windows obviously are there for passengers' use. So, trying to split a unique train vehicle into different areas, we identify areas such as the cab for a leading car, the deck interior, and more specifically the front deck and the back deck. In some of the vehicles you'll find the catering facility. Obviously in all of our vehicles you can see the saloon interiors where passengers can sit and travel. For every single vehicle there is wiring work, and obviously you find the bogies in the underframe and the exterior work, which includes the various CCTV cameras, painting work, pantograph installation, antennas installation, the roof and roof covers. I'll talk through a bit more in detail about the saloon interiors, which is currently my area of expertise, and describe you a few of the modules which are located within the saloon interiors, such as the seats, the ceiling, seats and tables, of course, the ceiling work, which also contains some of the equipment, such as speakers for passenger announcement, etc. We've got the installation of the floor, which might sound simple, but it's quite complicated because it has to comply with various regulations. We've got the luggage storage area, which it's also very essential as it comes at the very top of the list for our customers' requirements. We've got partition doors, which are the doors that separate the saloon area, the seated area, and the vestibule area, which is the area of the train you see as soon as you enter a train service. We've got the signage in the interior as part of our scope of work, which is essential to direct passengers inside the train vehicle, and obviously something very, very essential for comfort traveling, such as the insulation material that goes on the car body prior to any panel installation. So amongst all those modules, some of the ones that are very much at the top of our list of priorities as design engineers for saloon interiors is the seats. So on top of our list, the comfortable traveling is essential, and we pay very much attention on that aspect. So the seats go through a long stage of design development. They are also very challenging because they have to comply with various standards. Amongst those is the GMRT 2100, which I'm going to talk more in detail later in my presentation. The luggage storage is also a very important area of our work. We need to assess the capacity of the luggage storage and make sure that we comply with our customers' requirement. So all passengers using that train service are happy with taking their luggages with them and having enough space to store them during the travel safely. So I would like to draw your attention in a detailed development of the saloon interiors design. On this slide, you can see at the top a top section of the leading vehicle you saw in the previous slide. At the left-hand side, you can see the number one end of the vehicle, where the cab is, and obviously now you can see the windscreen of the driver. Moving towards the rear side of the vehicle, you go through the first vestibule area, which in this case is blocked for passengers. As you can see, the catering comes next to that vestibule area. So the catering facility is normally located in one of the two leading vehicles and can vary in length. Again, it's an area where customers can have their say. They can have specific requirements about the various facilities they want to include in the catering area. And so we make sure we accommodate those the needs. Coming through the partition, you come into the seated area, where in every project there is a different seat and tables arrangement. You can also see that within the seated area there is provision for the wheelchair space as well as a luggage stack. So on bottom right, and before you come into the vestibule area, you can see where the luggage stack is located. On purpose, I allow those dimensions to be shown for the area of rotation of the wheelchair. As per the PRM TSI, we have to comply with for that specific area to make sure that we provide a safe and an uninterrupted movement of the train and accomplish the required level of performance for the service. So this is a requirement that we have to comply with when we consider the location of the wheelchair and the amount of wheelchair spaces we provide on each service. It's also part of our customer requirements list to make sure that there are enough areas distributed across the unit in each project. So you can see that this circle of 1.5 meters is also outside of the toilet in the vestibule area. This is our universal access toilet, very commonly known as UAT. And the circle of 1.5 meters diameter is also highlighted in that area to make sure that there is direct and easy access to the UAT toilet. In some of our leading cars, you can also see a double capacity for wheelchair. So if in the seated area you take out one passenger seat, one standard passenger seat and the luggage stack, then you can replace those with another wheelchair space. So moving on into the vestibule, you can see obviously a top section where the external passengers doors are located. I've already mentioned the UAT. You can see the top view of the toilet, and at the very rear of this vehicle, it's the gangway area, which is basically the alley that leads you to the next vehicle of that unit. On the bottom left section, you can see that we've got a view of the rear part of the seated area where the wheelchair area is, and one single seat. So that rectangular panel you can see is the wheelchair support, and on the right hand side the single seat with a table in front of it. You can also see that I've added a picture of the seat arrangement testing, because I would like to talk a little bit more in depth about the development of the seat design. So as probably have mentioned before, the seats are very much prone to changes and customization, and for that reason we continuously test new materials and new arrangement, as well as a new type of fixtures, to make sure we always meet the various customers' requirements. We always have to comply, though, with the DMRT 2100 issue 5 section 6, which defines the type of testing we'll have to the type of testing we have to conduct prior to design freeze. In every project, the seats and tables are dynamically tested. The most critical orientations and arrangement of seat and tables are initially highlighted and eventually tested for degraded conditions and collision. We need to make sure that always safety and reliability are met, as well as technical compatibility and accessibility. So it is a great part of our work we have to go through during our design work, which eventually provide the boundary conditions for the finalized design to be presented to our customers. So we'll have to make sure we comply, first of all, with our safety regulations and structural integrity, and at the later stage, the aesthetic and comfort. Now I would like to move into the integration of train systems in the saloon interiors and give you a couple of examples for a specific area which is very much prone to changes and customer requirements. So on this slide you can see a top view of a section from the vestibule, from the threshold between the saloon interiors area and the vestibule. You can see in the middle we've got the two lifts of the partition door, and just above that area we've got the passenger information display located. Obviously on the sides you can see a section view of the luggage rack that runs across the whole length of a vehicle. We've got obviously the header panels, and at the very top we've got the ceiling panels. But I won't go into very much details about those areas. What I would like to note here is that the passenger information display provides all the essential information that passengers require during their travel. So that might include the final destination, the upcoming platform, and the starting point, for example. Here we can see a different type of monitor which we intend to install at a great vicinity to the passenger information display and provide real-time data to the passengers of that service. So this is a new type of monitor that we expect to have the Darwin system integrated. At the right-hand side, you can see a potential location for the integration of this monitor. This is a piece of work that's still under development for Hitachi Rail, and I've been working quite heavily in that over the last few months. You can see that obviously we've got various restrictions within the saloon interiors, physical as well as technical, to make sure that the monitor is positioned correctly and effectively. So the idea is to provide the passengers with real-time information, consistent information nationally and online channels. On the left-hand side of this slide, you can see a similar type of monitor already installed in one of our fleets. And as you may see, I don't know if the picture is clear enough, but it provides real-time GPS data showing the location of the train service at real time, and providing also information about expected time of arrival for upcoming stations. And this is a monitor that has come as a customer requirement to enhance the passenger experience and comfort while they use a train service. So in summary, I would like to highlight, as obviously Thomas has already said, train vehicle manufacturing includes a wide range of various systems and the combination of various expertise in engineering, manufacturing and design engineering, as well as practical and empirical skills and new technology that we have to adapt as every time in the future. So I presented you an overview of the design development for trains we undertake at Newton Aycliffe in the northeast of the UK. I'm currently working in the saloon interiors, making sure that for the areas which are still under design development, we comply with GMRT 2100 for the rail vehicle structure and passive safety standard, as well as the PRM TSI for safety and reliability. We always undertake suitable testing to ensure the safety, as I mentioned, and our train design is continuously evolving based on our customer requirement, passengers' needs, especially the saloon interiors and vestibule area are areas that are very much affected by our customers' input. And finally, new systems are integrated in the saloon interiors to accommodate effective traveling and happy passengers. So that was the end of my presentation. Thank you very much for your attention, and I welcome all questions, please.
Excellent. Thank you very much for that, Katrina. That was really interesting. We've had a few questions have come through. On the subject of testing, somebody's asking how are the seats and tables, etc., dynamically tested? And linked to that, someone's asking, are there testing facilities at Newton Aycliffe?
Thank you very much for the question, Andy. So the actual testing for crash worthiness are outsourced. We don't have a testing facility for that type of testing in Newton Aycliffe. We do have testing facility for the functionality of an assembly train, which obviously it's part of the manufacturing process, and it comes at the very end of the manufacturing cycle of a train unit. So we do the pneumatic testing, as previously Thomas mentioned, and dielectric testing, etc., but not for the seat design development. So this particular type of testing is outsourced. However, we do all the preparation work for that. So in order to comply with GMRT 2100, we'll have to make sure that the most critical table and seat arrangements are tested. So as first instance, we'll have to identify the areas of test. We then have to manufacture and design and manufacture the test specimens, and these are real size specimens. So for instance, it might as well be a section of a car body with a real scale table and seats fixed on floor as there would be in real train vehicle. So then that is up to our testing facility, and they do the testing. We then assess and conduct reports.
Okay, somebody's asked, do changes in train staffing, such as having guardless trains, does that affect?
Sorry, I didn't hear the last part of the question. Does this affect what? Sorry, yeah.
Sorry, do changes in train staffing, such as guardless trains, affect the design of the trains?
Yes, absolutely. We had an opportunity to work for the assembly and manufacturing of a driverless metro vehicle at Newton Aycliffe. This is a type of metro train, 8100, made for a city in Italy, and it's a driverless one. And obviously that has a major impact in the interiors design as well as the system architecture. Obviously there's no cab area as such, so you can understand very quickly that the design is massively affected.
Thank you. It is clear that accessibility is considered within the design. Is this done based purely on established industry standards for wheelchairs, or are there other methods used to gather requirements from the users of those areas? How are other kinds of diversity considered and provided for in designs, such as tactile elements for the blind?
So PRMTSI is European standard that the UK has to comply with. It came into force in January 2012, and the Department of Transport is responsible for this standard. So it's a technical specification for passengers with reduced mobility. And as I mentioned, it's a European standard that makes sure that there's a safe and uninterrupted movement of the passengers within the train service.
Okay, thank you. I think we're sadly running out of time, so I think as a last question, what sort of reliability methods do you all use? FMEA, etc.
So is that defined element?
Sorry, it's just
Katrina, I think it's failure mode effect analysis.
Right. Okay. All right. Yeah. Okay. So yeah, as design engineers, we don't do any of that. Thomas mentioned our systems integration engineers who do a lot of that type of work. They're based mainly in London site. And obviously, in terms of reliability, that's part of service and operations department. So there's a lot of work done in our depots to make sure that reliability and performance are always up to a high standard.
So if I can add just a quick thing, in this case, the RAMS engineer would be in charge of these, and then there will derive some spec that will be part also that they are going to integrate the design spec of the technical specifications, and then for us our input as a design engineer. So we don't do this activity.
Okay.
Thank you very much.
No problem. Thank you. And sadly, that's all we've got time for. So I think I'll draw this evening's event to a close. Just like to thank Katrina and Thomas for their presentations. And for giving up your time today. And thank you all for attending this afternoon's event. I hope you've all enjoyed the hour, and I hope you all have a good evening. Thank you very much.
Thanks to everyone and to all attendees. Yeah, thank you very much.
Thank you.